Bismillahirrahmanirrahim. Today we learn how the three-phase rotating magnetic field, that when three-phase supply given to an induction motor, how the field will be in rotating, right? So today we study rotating magnetic field. Let's just start with the drawing the wave diagram of all three phases: red phase, yellow phase, and then blue phase. So start drawing the wave diagram of three-phase red, yellow, blue. So make the intervals. This 30, then 60, then 90, then 120, then 150. We know that the total is 360, right? The rotating phasor is the total sinusoidal wave cover a sinusoid cycle that goes to up till 360, right? So make the intervals of 30, 30, 30. So 150, 180, 210, 240, 270, 300, 330, and 360. So we have 30, 30 intervals. Now we are going to draw our first phase, that is red phase. Red phase, right? So we know that the red phase is a reference phase, and it starts from 0 degree. This one is 0 degree, right? So it starts, and the peak will come on 90 degree. See, the phase start, the sinusoidal waveform. The peak arrive at 90. Then at 180 it becomes 0. 180. Then the next peak, the negative peak, is at 240, right? See, the 30, 30 intervals. The first 30 interval, it's positive peak. The next 30 interval is 0. The next 30 is negative peak, and the next 30 is 0 again, right? 30, 60, 90, 30, 60, 90. So that's how the sinusoidal waveform, that is rate phase. See, first 30 intervals, 30, 60, 90, 30, 60, 90, 30, 60, 90, 30, 60, 90, right? Negative peak, positive peak. Positive peak at 90 degree, negative peak at 270. You can verify sine 0 is 0, sine 90 is 1, is maximum value, that is 1, right? So you can verify these values. This scale is magnitude, right? Magnitude of voltage or current, right? Magnitude of voltage or current or flux. Same thing, right? Vm, Im, that is the magnitude of Vm or Im or phi m. Vm, Im, or phi m, right? Now the next phase starts, that is yellow phase. Remember that yellow phase starts after 120. We know that all three phases are 120 apart from each other. So the next phase starts from 120, that is from this interval. The next phase start. The next phase, that is yellow phase. This was red phase. So 30, 60, 90. The peak comes over here. The yellow phase. I don't have yellow color, so I use green, right? So then again 30, 60, 90. It will become 0. And again it goes like, right? It goes like, and similarly it comes backside 30, 60, 90. The negative peak, right? So see, this is red phase, this is red phase, the red phase, the yellow phase, right? Now the blue phase. Blue phase starts from 240, because blue phase is after 240, right? From red phase. Blue phase starts after 250 from red phase. So start your blue phase now. It starts from like this, 30, 60, 90. The peak comes over here, 30. Similarly backward, 30, 60, 90. Similarly 30, 60, 90, and it goes like this, right? So this one is red, yellow, and this one is blue phase. Right, so you see all the phasors, right? 30, 60, 90. This one is red phase, this one is yellow phase, and this one is blue phase. Red phase starts from reference value 0 degree, yellow phase starts from 120 after red phase, and blue phase starts 240 after first phase, that is from red. Okay, if you see from yellow to blue phase there is 120, right? From 120 to 240 the interval is 120, right? From 0 to 120 the next phase, right? And so on. Now draw is phasors. So we know that our phasors are we can draw it like see the all phases that are 120 degree apart from each other, right? So this one is reference phase, red phase, this one is yellow phase, and this one is blue phase. It is 120 apart and it is 240 apart, right? So these are the phasors. So now at any instant when we sum up two phasors, what happens? Now focus here. See, for example, at this instant, that is 0 degree instant, we have yellow phase and we have blue phase, right? But yellow phase of negative vector. See, yellow is negative and blue is positive, right? So first of all, draw the negative of yellow phase, right? Because yellow is negative. Yellow is negative, right? So negative of yellow is exactly opposite direction. Negative of yellow is what? Exactly opposite direction. See, this is negative of yellow phase, right? Why? Because negative of yellow adds with the positive of blue. So this is, say, this is also vector, that is phasor of yellow phase, and this was 120. Originally this angle was 120, but when this phasor come, it will bisect 120 to 60 degree, right? So red and yellow, see, yellow and blue, sorry, the yellow and blue phase are add up at these points, yellow and blue phase. So blue phase is here, yeah, and the negative yellow phase is here, means B minus Y, right? Blue phase minus of yellow phase. Blue phase minus of yellow phase. So this is minus Y, this is minus Y yellow phase, this is positive B. These two vectors are added, right? So the resultant comes some like, the resultant comes over here, right? The resultant comes over here, right? This is resultant, this is phi r, resultant vector of fluxes. These are the fluxes waveform, right? Because we are studying rotating magnetic field, so these are fluxes. So come to the next point. For example, this point. At this point the blue phase is 0, but see, at this point the red phase is positive and the yellow phase is negative, means negative yellow and positive red are at each other, right? So negative yellow is always there, already drawn over there, positive red is there. So the equivalent vector of negative yellow and, see, this one is r minus y, this point, right? So the resultant comes over here, the resultant comes over here. Now come towards this point, see, this point, red is positive and blue is negative. Now red is positive but blue is negative, right? This point, that is 120 degree. So draw the blue negative vector. The blue negative vector, draw exactly behind it, right? The negative blue vector, the negative blue vector. अच्छा वो थोड़ा सा यूं था, the negative blue and the positive red, right? So resultant is somewhat here. The resultant is here. So this is negative blue and positive red, right? The resultant. The resultant. Now you can see the resultant. See the resultant vector. It rotates. See, it rotates, right? So when you come up to this point, that is 180 degree. This point, red is 0, but yellow positive and blue negative. Yellow and minus YB, right? Minus B is also is there, and this one is yellow phase, positive yellow minus blue phase. So equivalent of these two vectors, right? Equivalent of these two vectors. Equivalent of red and these two vectors. See, resultant comes over here. So now comes towards this point, 240 degree. See, positive yellow and negative red. Now you have to draw negative red vector. Negative red is exactly opposite negative red, right? So now negative red and positive yellow. Yellow minus R. Okay, positive yellow, negative red. So see, positive yellow, negative red. So equivalent comes over here. See, equivalent vector. Equivalent vector comes here. See, the equivalent vector rotate. See, equivalent vector is rotating a phi r. See the phi r, right? So now comes towards this point, 270. This point, sorry, 300 degree. See, 300 degree. The blue phase and the negative red phase. Blue phase and negative red phase. Negative red phase is there, blue phase is there. So equivalent is, see, equivalent is, right? This is equivalent. So see, in this whole diagram, you see the resultant vector is rotating. First, the resultant vector was here. Then resultant vector comes over here. Then resultant vector come here. Then resultant vector come here. Then resultant vector go here, right? So it rotates actually. It rotates, and we come up with the 300. We can go 360, right? So you will come cover up. If you say we will cover up 360 also. At 360, see. At 360, the blue phase is positive. See, the blue phase is positive 360, and the yellow phase is negative, right? The yellow phase is the blue phase means negative yellow and blue phase are add up together, right? So it comes over like here. So it rotates actually. I hope you understand very well the rotating magnetic field. That's how the rotating magnetic field, we call it the rotating magnetic field. It rotates with the speed 120 f by p. That is the synchronous speed 120 f by p. F is frequency, p is number of poles, ns is synchronous speed. When three-phase AC supply given to stator of the induction motor, a rotating field is produced over there, and that's how this field is rotating, right? See these vector diagrams. The field is rotating, so that's why we say rotating magnetic field. It rotates with the speed of 120 times frequency divided by number of poles on the machine. So this is how the rotating magnetic field is produced in AC machines, in for example induction motors. I hope you understand. To actually phasor diagram was not so clear, so again I want to draw the phasors for the rotating magnetic field. So this one is our red phase, then this one is our yellow phase. Red phase is 120 apart from yellow phase is 120 apart from red phase, and the blue phase, that is 240 apart from the red phase, right? These are same as ABC, right? Phase ABC, phase sequence ABC, same, right? So red phase is 120 apart from yellow phase is 120 apart from red phase. Blue phase is 240 apart from red phase. Red phase is reference phase. So when we add up, actually in the first phase we have the value that is blue minus yellow, right? So you have to add two phases, that is from blue phase, blue negative, you have to add the yellow negative with the blue phase, right? This one is blue, this one is yellow. First of all, draw the yellow negative vector. Yellow negative vector goes like this is a yellow negative minus y, right? Exactly opposite, right? Exactly opposite, this is minus y, right? And this, because this is 120, this resultant will bisect 120 to 60 degree, right? So we have to add blue minus yellow, that is blue positive with the yellow negative side. So their equivalent comes over here, right? See, the equivalent of these two, the equivalent of these two will come over here. This is a resultant vector, right? Blue minus yellow. And what was the other? You have red minus yellow, then you have red minus blue, then you have yellow minus blue, then you have yellow minus red, and you have blue minus red. See, blue minus yellow, red minus yellow, red minus blue, yellow minus blue, yellow minus red, blue minus red, right? So the second case is red minus yellow. So you have to add this positive red with this negative yellow, right? So add up these two, you will get your rotating phasor. See, you will get the resultant vector for red and minus yellow, red and minus yellow over here. This was okay, this is this one. Now in the next phase you have to add red minus blue, right? So you have to draw the blue negative vector, right? So blue negative vector is exactly opposite to is, see, this is minus blue, and you have to add up minus blue and red, right? So when you add up these two, your resultant vector is come over here, okay? Resultant vector, and this is a red minus blue, this one, right? In the next case you have yellow minus blue, this is yellow, this is minus blue, right? So the resultant is some like comes over here, the resultant, this is the case for this yellow minus blue, right? Then you have yellow minus red. So you have to draw the negative vector of red, that is negative vector of red, this is minus r, it is adding with the positive yellow, right? So the resultant vector comes over like here, this is the resultant vector. Yellow minus red, yellow minus blue, sorry. Now yellow minus, this is yellow minus red, now blue minus red, blue positive and minus red, right? So you see minus red and positive blue, so resultant vector comes over here. Now in this diagram it is very clear, see, the resultant vector, first of all it was in this direction, then resultant vector come over here, then resultant vector rotates, it comes over, then resultant vector comes over here. From this to this is 180, right? From this to this is 180, and from again this rotation, see, yellow the resultant magnetic field vector is rotating, right? Rotating, and it comes to our this point. So in this way the rotating resultant vector is rotates actually. So this is rotating magnetic field, right? I hope you understand. These phasors are much more clear than before, right? These phasors are clear and very easy to understand. Thank you.